Okay, so far we've talked about concrete, which is referred to as dynamic mass. That means that it's monolithic. It has solid mass to it, so that can be extended up into the walls and even into the roof here. So that concrete is you're surrounded by concrete, which is especially good here and better than wood, I would say, at those ballistics we talked about, tornadoes. So some of the only homes that survived, it's proven by places like Moore, Oklahoma, and down in Oklahoma, is the concrete walls. And I think like I said, if you get on Texas Tech's website, you can see that the concrete does pretty well, anywhere from 4 to 6 inches thick. So dynamic mass, meaning dynamic, meaning that it can absorb heat, hold it, release it when it gets cold at night, and then it can also hold and release moisture and keep the relative humidity in the house at a desirable temperature. Humidity level. That's usually 30 to 35% humidity is desired for those mold and fungi and properties that I discussed there earlier. So here, though, in what we've done here and what most builders are doing out here in Wichita and across our nation, even we've not only, like I said, are addicted to concrete, but we're also addicted to wood. And so we have here what I'm showing is our 2x6 walls. The industry standard out there that you'll find are 2x4 walls. That's one way we get each one of these stud cavities are filled up with insulation. So that's one way we get our insulation values up. But there's more to it than that. There's also in our designs, there's an engineered gap between the stud and another layer of insulation, what's called an outsulation, meaning that we kind of wrap the whole house. In addition to putting insulation in the stud bays here, in these stud bays, in between these studs, we've also done an outsulation. We've put a big blanket of insulation all the way around the house, and then between the two, we have a ventilation gap that's running here. You can kind of see the furring strips here running on each one of the 2x6 studs. And so there's a gap here, and it's just not a gap, though. There's more to it than that. A lot of builders and designers that don't know any better think, so, okay, I just throw a gap up there and I'm good to go. Well, the purpose of the gap is so air flows around this entire house. So it's almost like you got a house inside of a house. What that basically does, that ventilation gap, when we go to put that siding on that you see in your curb appeal of the house, when you're looking at it, that preserves it better. So, I talked about how the vapor drying, how it needs to occur. Well, out of the wall and into the interior, there needs to be drying in neither direction. So we've allowed with this gap here that has a certain flow, and that flow it needs to be verified that there's actually air flowing through here, so we could vapor dry into that gap. So there's more to it than that. There's what they call insulated concrete forms. I'll get into that in a minute. There's some issues with them I'm going to discuss here in a minute, and then we also have a new a wall assembly on the market called structural insulated panel, where they take that polyurethane foam that I discussed the problems with it. It acts like a vapor barrier, and they glue into some OSB, a particle type of board that's glued together, and that whole assembly is not going to dry in any direction. So that's just a vapor lock, and there's some issues, especially when those kind of panels come together at the seam. So get with me on more of that if you're interested. If you're about ready to make a decision on a SIP or an ICF, you definitely want to talk to a qualified engineer about some of those issues. They're out there. It's amazing what computers can do these days. Maybe you're pretty impressed by some of these models I'm showing you, but the other thing they can do, it's more important, that a lot of architects and designers and builders don't have the capability to do, is called fluid dynamic modeling. So we can go out and there's climate towers here that we know that we get our weather from here in the Wichita area, for example, and we could pull that into a simulation model that runs a bunch of airflow around the building, around homes, and they do it. It came over from Germany, and Germany has really got it down to a science. They got what's called a WUFI model. It's a fluid dynamic model. So, like I said, these gaps, you just don't throw them out there and hope for the best. There's some engineering involved in that. So now we've taken that's called passive solar or passive Passive Institute US is now we got a new German type of design philosophy that came over, and they're training people around the country and whatnot, and builders and tradespeople how to build these airtight homes with the right flows and whatnot. So that building science term is really taking off with the green movement, like I said, but there's a lot to know there, so you want to make sure the right person's doing it. Everything I just said applies to the roof as well. So basically, let's conclude here by saying that there's two basic types of ways to design the walls and the roof. One is a very highly insulated, where you have a bunch of wood, layers of house wrap. The house wrap doesn't really provide enough gap. It tries to, but when you go to push those panels up against the stud, you get it's called the thermal bridging, that conduction again, that resistance to flow, conduction meaning that the heat goes right through the siding and the house wrap doesn't provide enough gap, and then or it doesn't provide enough airflow in a lot of cases to take care or providing a vapor drying path, and then that heat, if you were to again take a heat gun to one of these studs and you're stacked up a bunch of solid wood on top of it, the heat can just go right through the wood and from the interior out, or the cold can get from the exterior in right through all these studs. And you see, you can look up on the internet some pictures here up on the roof where there's snow up here, and you can see each one of these studs have heated the snow due to the thermal bridging. I should say, and you can see that the home's losing heat that way. So we don't want that. That's why we come back here and we wrap the house. We put a ventilation gap in there to break that bridge and provide the right gap again. So that's pretty much it for walls. There's a whole lot more to it I'm not going to go into. If I'm losing you and things are getting complicated, things do get kind of complicated with building science. Just feel free, if you're interested in buying one of our homes, email me, call me, and I will sit down and try to explain it in a way that you understand. So we talked about mass, and we talked about an ability for the concrete floors. We have hydronic radiation in these floors. It's very therapeutic. We utilize the mass of the floor, this mass down here, and we run some water through it. Water's got the best heat carrying capability in it, far better than air, 1,000 times better than air and blowing air around here. So we utilize it with the mass and to emit out a very comfortable therapeutic heat that doesn't have a bunch of nasty microbials running around your indoor air quality. Another thing that we offer as an option, this is an American clay product that is very nice, very beautiful, that we can put on the walls here to help increase that thermal mass and that moisture holding capability in the house. You put an inch or two of this stuff inside your house. What that does is because it's taking down the humidity level and storing it in the walls, then the cooling system doesn't have to be turned on to dehumidify the place and give you that cool feeling. So that helps out quite a bit, especially here in the bathrooms. You can see some other colors that they have here in the bathrooms. If I get up close here, you can see it's kind of got a two-tone. You got all different kinds of options on American Clay's website. If we also have better proprietary blends, lime, other types of materials. Think about lime here. It's nowhere close to OSB. It doesn't degrade or wood or some of these other floor laminates and glue products. It doesn't start degrading when it sees moisture. It actually improves. Lime, for example, is limestone. So when you put the stuff on your wall, every time it sees moisture, it's actually trying to convert back to a rock, so it absorbs and holds that moisture that these other materials don't do. They degrade, and it just gets stronger and stronger and stronger. So, like I said, not all materials are created equal. There's a lot to know about the type of materials that are in your house and whether or not they're going to deteriorate in time, and whether or not they're improving the indoor air quality, and either they repel moisture or they love it. In the case of lime and earth plasters and different types of natural finishes that we've been known for centuries, they get better. Those are the kind of things that the manufacturers don't want you to know. You can find some of these materials in your backyard. The building sciences won't promote them, and you won't find them in building codes. I mentioned briefly in the Paraflat and the Paraflex videos about the ventilation systems that we're putting in these homes because we blower door tested them. And so there's two different types. There's what's called a heat recovery ventilation system that doesn't help manage the indoor humidity levels and keep those cooling bills down. There's also an energy recovery ventilation that does, and so it's got a decant material in here. Air comes from outside, passes through a heat exchanger and a moisture transfer exchanger, and then it comes into the house, ventilates it, and comes back out. I mentioned the plumbing systems, just like everything else that I've discussed. If the plumbing connections aren't correct and the types of materials that are being used that are joined are incompatible with each other, there will be a galvanic reaction and a bunch of junk accumulating at those connections. Thanks for watching. Hopefully I didn't lose you. If I did, feel free to contact me and I'll try and explain in a way you can understand. But I hope that now you're better educated and informed on what to look for in selecting your next designer and builder. Again, Terry Portier, Paramount Homes and Construction. Hope to be talking to you soon. Be sure and check out my energy modeling video on our website. If you go out to YouTube, I also have a playlist there. You can watch all the videos. Below that energy modeling video, if you go to the Show More icon and click it, you'll see a bunch of informative links. In the energy modeling video, all this comes together, and I show you some weather simulations where I put the Paraflat in and surrounded by Wichita weather, and I compare it to the average home. It gets pretty interesting, and I try to make it simple, so hopefully it'll make sense. Hopefully that video will make you aware where things are now and where they're heading into the future and how the Parahome meets those requirements. And you'll see a big difference in the way that we engineer and all the engineering that goes into our homes and what to look for in other designs. When you're going out shopping and comparing, you should be able to sit down with the designer and look at those similar types of simulations and information that we provide and output reports and whatnot. So hopefully that will help you in your shopping adventure.